Okay, so for level ones, I can simplify square roots and cube roots and numbers and variables. So very similar to our last objective, but now we've just got variables to go along with it. So in letter A, I'm going to break this down into two parts. The square root of 4 times the square root of a squared. So I'm going to break this down separately. The square root of 4 can be broken down into 2 times 2, and a 2 can come out with nothing left over. For a squared, I can break this down into a times a, and since there's a pair of similar terms, I can bring those out with nothing left over. So my answer is just 2a. It works very similar with cube roots. I'll go ahead and break this down separately. So if I'm breaking 8 down, 4 and 2, and then 2 and 2, and here's a group of 2s so they can come out. Nothing is left over from the root. X to the 6th can be broken down x squared times x squared times x squared. Because remember, if you're multiplying these numbers to those variables together, all you're going to do to simplify it is add the exponents. So that does get us back to x to the 6th. So now I have a group of the same term. They can also come out. And your answer is 2x to the 2nd because nothing is left over for the roots. For letter C now, we've got a lot of things going on. So I'm going to break this up again, all separately. The first term, 3b to the 3rd, and I've got the square root of 48, the square root of b to the 4th, the square root of c to the 7th, and the square root of d to the 10th. So 3b to the 3rd in the beginning doesn't really get us anywhere. So I'm going to leave that guy alone for now. And I got the 48, so 16 and 3, 4 and 4, and I'm looking for groups of 2. So the 4 can come out. I'm going to bring down the 3b to the 3rd times 4 square root 3. For b to the 4th, I can break this down into b squared and b squared. And there's a pair with nothing left over, so b squared just comes out. For c to the 7th, I can break this down into c squared times c squared times c squared with one c left over. Remember, again, if you're multiplying variables with exponents, you add them. So that's how we kind of want to think about going and breaking down a variable with an exponent. So since there's a group here, I'm going to have, I'm sorry, hold on. So going back. So if you've got c to the 2nd, this is a good example of when you break down something that's not exactly the best way, but you can still figure it out. So you got c squared times c squared times c squared times c. So here's a pair of c to the 2nd, so they can come out. And now you're probably thinking, well, c to the 2nd doesn't have another pair, and neither does c. But if you realize c to the 2nd can be broken down into c times c, so really there is another c that can come out with one c left over now. So the best way to break it down, c to the 7th, would have been c to the 3rd times c to the 3rd times c. That would have been the best way. But either way will work, just like breaking down numbers. Any way you break it down, it will still come out the same. There's just one faster way to do it than the other. For d to the 10th, the best way is d to the 5th and d to the 5th. So a d to the 5th can come out with nothing left over. So now I'm going to put the numbers together, the variables outside the roots, and the variables and numbers inside the roots. So I got 4 times 3, which is 12, b to the 3rd, b to the 2nd, which is b to the 5th, c to the 2nd, and c, which is c to the 3rd, and then I got a d to the 5th. And for our roots, we've got the square root of 3 times the square root of c. Now remember, even if the roots aren't the same underneath, you can still multiply. Right? So your final answer is 12, b to the 5th, c to the 3rd, d to the 5th, root 3c. For d, I'm going to break it up very similarly. The cube root of 81, the cube root of p to the 12th, and the cube root of q to the 8th. So breaking down 81, I'll have 9 and 9, 3 and 3, and 3 and 3 again. So here's my group of 3 with the 3 left over. For p to the 12th, you can break this down into p to the 4th, p to the 4th, and p to the 4th. Right? Looking for groups of 3 that are the same, you got p to the 4th that comes out with no root. Q to the 8th can be simplified as q squared times q squared times q squared times q squared. Now, again, you're looking for groups of 3, and you've got a group of q squareds. And now again, just to check, q squared breaks down into q and q, but because it's a cube root, I need groups of 3. So this one will stay underneath the radical. So now multiplying numbers together, I got 3 p to the 4th, q to the 2nd, and then I got the cube root of 3 q to the 2nd. So one quick thing that might be a little shortcut for you, and you might even be thinking this, is whenever you have a root, so like the cube root, and you've got exponents, all you're really doing is dividing the exponent by the root. So in D, if you're looking at, okay, 12 divided by 3 for the p, that's 4, and that's what came out in our answer. Now how about q? Well, 8 divided by 3 doesn't go unevenly. The maximum number is 2, which is why we had a q to the 2nd come out, and there's a remainder of 2, which is why there is a 2 left inside, because 3 times 2 is 6, and to get to 8 I need 2 more, so that's why the remainder comes from. So that's with cube roots. With square roots, it's very similar. You're just dividing by 2 and determining if there is a remainder. If there is a remainder, that's going to go on the inside. So I'll practice it as the videos go on and show you that it's really just dividing. You don't have to worry about breaking down the variables as much as the numbers.